Hey guys, we are ready to start part 2 of our lesson 6. So I just want to show you the Desmos calculator. In order to do what we need to do today in the Desmos calculator, I need you to click on this little tool set over here on the right. Okay, and in order to do what we need to do, I need you to change this from radians to degrees mode. Radians to degrees. And then we will be using the calculator tool down here at the bottom. So we would just open this up, okay? And we will come back here and look at these functions. These are trig functions. We're going to be using these three and these three for our lessons, okay? So remember, sine, cosine, tangent. We're going to use these three to find the lengths of missing legs. We'll use the ones with the -1s to find missing angles. All right, so let's go ahead and return to our notes, which are zoomed in too far. Alrighty, so today this part of our video is going to be finding side lengths using trig. So I've highlighted this here. Make sure that your calculator is in degree mode. And I just want to introduce you to a new symbol. This symbol is theta. I do it kind of sloppy. Theta is just what we use when we have an unknown angle. Okay, so when we set up our trig ratios using these problems over here, we're going to do whatever function it is that we need. The angle measure will go where the theta symbol is, and then our ratios will remain the same. So sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. And again, we will be using the Desmos calculator to simplify all of our problems today. So let's come up to example 1. I'm going to zoom in. And I've already started labeling some things in example 1. So the angle that we know right here is 28 degrees. That's going to be our theta, okay? So from this angle, this is what determines which function or trig ratio we will use. So I need to determine what side measures am I given. So I know the opposite is x, and then I know that this side is the hypotenuse. So I need to use the trig ratio that uses opposite and hypotenuse, which is the sine function. Okay, so sine of 28 equals the opposite over the hypotenuse. And it's that simple, okay? So the angle measure is what goes here. Now, let's solve this to get the x by itself. In order to do that, we will need to multiply both sides by 19. And here's how that looks. 19 sine, whoops, I actually started to spell the word sine, 28 equals x. And so what we do to actually simplify this and find the value of x is we come on over here to our Desmo calculator, and we are going to literally type 19 sine 28. When we type it, we're going to put parentheses around the angle. So let's go do that. So I'm going to type 19 sine. It already opens up the parentheses for me. I'm going to type in the angle measure and close my parentheses. And notice that in this little box here, it already pops up and gives me the solution, 8.9. 8.9. So when I come back to my paper, the value of x that I'm going to put on my notes is 8.9. And that's it. Let's take a look at number 5. So if you notice, I have highlighted in yellow the missing side length. So wherever the x is, I've highlighted. Okay. So for number 5, my theta is 41. So there's my theta. I know that the x is opposite of that angle measure. And I know that the 32 is the leg touching this angle. This over here is the hypotenuse, remember, because it's opposite the 90-degree angle. So which one of our trig ratios uses adjacent and opposite? Adjacent and opposite. That is our tangent function that uses opposite over adjacent. So let's go ahead and fill in our information. So tangent, my theta is 41 degrees. Opposite is x. And then adjacent is 32. So same as before, I need to multiply both sides by 32. And I get 32 tangent 44 equals x. The only way that I can evaluate this is by typing it in to my calculator. So let's go do that and see what our value is. So I'm just going to delete this out of here, and I'm going to type in our new problem. 32, click on the word functions, and we're going to use the tangent, okay, and type in 44. And look, our answer popped right up there for me, 30.9. I didn't even have to close the parentheses. Okay. Whoops, I mistyped. Sorry, I typed 44 instead of 41. There we go, 27.8. 27.8 is my solution. That's the length of the missing leg. So let me go back to my notes. Okay, 27.8. Let's now do example 6. Okay, so my theta is 21. I need to determine the information that I know. Okay, so the leg next to it is x, so that is my adjacent side. The other side that I know is opposite the 90-degree angle, so this is my hypotenuse. So which trig ratio utilizes adjacent and hypotenuse? So I just refer to this list. Adjacent and hypotenuse are together here. So I'm going to do cosine of theta equals adjacent over hypotenuse. Now I'm going to fill in all the information where it goes. So cosine of 21 equals x over 26. Let's multiply both sides of our equation by 26. And then let's go ahead and go to our Desmo calculator, and we're going to type this in. 26 cosine 26, click on functions, choose cosine of 21. And my answer is 24 point, I'm going to round this 2 up to 3 because that 7 is greater than 5. So 24.3. And now I'm going to go back to my notes. And there's my solution, 24.3. Here's what I'd like for you all to do right now. I'm going to zoom out a little bit. I have examples 7, 8, and 9 here, and I want you to try them, okay? Just be sure to identify your theta, your sides that you know, and then fill in which trig ratio are you going to use, okay? So go ahead and pause your video while you work on these three. All right, guys, welcome back. I kind of paused on 8 and 9. I got as far as I could get, and I realized that my x value is in the denominator over here of my ratio. So what I need to do is to switch this around. Now, there is a way I could show you how to do it. Let me grab some scratch paper. Okay. So if I'm going to work this out, here's what will happen. I'm going to put this over 1 and I'm going to cross multiply because I have a proportion. So it would look like this. Sine 33 over 1 equals 15 over x. Then I would cross multiply and get 15 equals x sine of 33. But I still need to get this x by itself. So what I would do is divide by sine of 33. All right. And so these would simplify and reduce, and I'm left with x equals 15 over sine 33. So you could do that work for every single problem where your x value ended up on the bottom, okay? Or here's our little shortcut. All you need to do, notice that the 15 is on top, and just the sine 33 and the x changed places. The sine 33 is now in the denominator, and the x is by itself on the other side. So my shortcut, so I don't have to work that out every time, is to switch these two, okay? So now I know x equals 15 over sine 33. And for my example number 9, again, all I need to do is switch these. And so now I know x equals 36 divided by the cosine of 43. And we're going to go put these in our graphing calculator real quick. I'll show you how to do these with fractions. Okay, so let's delete this. So I'm going to type 36 divided by, whoops, I forgot to click divide, divided by, and it automatically turned that into a fraction for me. And now I can type my function, cosine of 43. And so my answer for number 9 is 49.2. Let me do that again for my example number 8. So I get 15 divided by sine. It won't work if you type it in. You need to come over here and click it. So over the sine of 33. And so my answer here is 27.5. Great job, guys. Great job. Let's come back to our notes here. Alrighty. We are going to, now that we've got these double triangles happening, we are going to need to find this side DC, and I've highlighted it for us, okay? but I don't know any of the side measures for any parts of this triangle. So I'm going to need to start over here. I have one side length and I have an angle. This side length is the hypotenuse for this triangle. Okay. Which of the other sides is going to help me gain a piece of knowledge about this larger triangle? Well, it's going to be this side right here. So let's just call that X. So we're going to go ahead and solve this for X. So I know, let's see, X is opposite. So I know the opposite and I know the hypotenuse, which means I'm going to do cosine of 54 equals the, I'm using sine, I'm sorry. Sine is opposite over hypotenuse. Okay, so 20 sine 54 is X. If I type that into my graphing calculator, what I find is, I'm going to find my cheat sheet real quick because I've already typed it in. Alrighty. That is going to be 16.2. Okay, so now I'm not quite finished. I know this side is now 16.2. And I need to use that information with this angle to figure out this side. So starting with this angle, I know the opposite, and I need to find out the adjacent. Okay, let's just call this Y. So opposite and adjacent is going to be my tangent. Tangent of 28 equals 16.2 over Y. Remember our shortcut, we're just going to flip these around. So Y equals 16.2 divided by tan of 28. And when I type that into my calculator, I get 30.5. All right, great job, guys. Great job. All right, guys, let's go ahead and do example number 11 together now. Okay, so again, we need to find side KL over here. I've highlighted it in yellow. The only thing about this triangle here that I know is one angle. So I need to look at this bigger triangle first. I know an angle and I know a side length, okay? So from this particular angle right here, this side is adjacent to it. And then which other side of the triangle would be beneficial for me to find to help me with this triangle? And it's going to have to be this opposite side, okay? Side X. If I found this side right here, that wouldn't give me any information about this second triangle. So that's kind of how I choose. Now in this case, the X is opposite the 51-degree angle. So I have opposite and adjacent. So I am going to use tangent of 51, where my opposite goes on top. Sorry, that should say equals, and my adjacent is on the bottom. Okay, and so what I need to do is multiply both sides by 14, and then go ahead and type this into my Desmos calculator. When I do that, I will get 17.5. So that is the first part, 17.5. So now I'm ready to move into this second triangle. Okay, I know that I'm working with this 70-degree angle now. And this 70 or 17.5 is the hypotenuse of this smaller triangle. So what is the side that they're asking me to find? This is the adjacent side. So I have adjacent and I have hypotenuse. So I'm going to use cosine. Cosine of 72 equals the adjacent over the hypotenuse. All right, adjacent over the hypotenuse. And so now what I will do is just multiply both sides by 17.5. And that will give me, I'm still using X. You could give that side another letter if you want to. And just know that whatever I get here, this is my final answer for that yellow highlighted side. So when I type this in to Desmos, so let's just go do it real quick. Typing in a decimal is no different than typing in anything else. Okay, 17.5 cosine, so click on the functions button, cosine of 72. And so the answer here is 5.4. 5.4. Did I type it right? Okay. 5.4, and that is my final answer. Okay, we're almost done with this second part of our notes. I just do want to show you a couple of application problems. All right, Jake leaned a 12-foot ladder against his house. So this is my very bad drawing of a scary looking house. And then this is the ladder that he's leaning. If the angle formed by the ladder and the ground is 68 degrees, so it's got to be the corner with the ladder in the ground, not the house in the ground. How far from the base of the house did he place the ladder? Well, they told me that the ladder was 12 feet. 12 feet. Okay. Now a house meets the ground at a good angle, right? We always have stable houses, hopefully. So I filled in the information. Now I'm ready just to apply this. So I know that my angle measure is 68 degrees, and I have the hypotenuse, that's the 12. They want me to find how far from the house, the base of the house, is the ladder. So they want me to find this, which is the adjacent side. So which uses adjacent and hypotenuse, and that's cosine, where the adjacent goes on top and the hypotenuse is on bottom. If you type this into your Desmo calculator, you will get 4.5. 4.5 feet. Remember, you would just multiply by 12. Okay, let's look at example 13. A ramp is used to load suitcases onto an airplane. So this is like the bottom part of my plane. This is the ramp, okay? If the cargo door is 7 feet from the ground, so this is 7 feet up, and the angle formed by the end of the ramp and the ground is 25 degrees, how long is the ramp? So in this situation, I have my angle measure, 25. I have the side opposite that angle, and I have my hypotenuse. So what uses opposite and hypotenuse? And that's sine. So the opposite is 7. The hypotenuse is x. And just don't forget our shortcut here. Swap these two. Okay, so x equals 7 divided by sine of 25. And again, we just typed that into Desmo, and I'm going to get 4.8. Okay, I'm getting, no, I'm sorry, 16.6, 16.6. I was looking at the wrong number. So if we just want to double check this in Desmo. Alrighty. Again, I'm just going to type 7 divided by sine of 25. And the answer is 16.56, which rounds up to 16.6, which is my answer. And so what I found was how long is the ramp? All right, that is part 2 of our video. And everything that we just did was we were given an angle and we had to find a missing length of a leg.